So far, this unit, this triad, we've talked about how we simplify square roots. That's kind of how we started it. We did factoring, prime factorizations, and we talked about how to simplify square roots. And then we use that to add and subtract square roots when they're like terms. Then we talked about how to multiply square roots. That's what we did last week. And now we're going to talk about how we divide square roots. Now, the number one thing we need to keep in mind when we're dividing square roots is that we are not allowed to have a square root in the denominator of a fraction. Which part of a fraction is the denominator?
Bottom.
The bottom, right? So you're not allowed to have a square root in the bottom of a fraction. All right? So what we're going to do is when we divide square roots, all of these are division problems. Why are these division problems, by the way? They're all fractions, and fractions mean division, right? So they're all division problems. And so what we need to keep in mind when we're doing division problems like this is we are not allowed to have square roots in the denominator. So there are two answers up here, or two expressions up here that are not allowed. Which ones are they? The first one, because it has a square root of 2 in the denominator, and the last one. The second one's actually okay. So when we divide square roots, sometimes we're going to get answers that look like this, and that's okay. We're going to have square roots in our answer sometimes, just like when we were adding square roots or multiplying square roots, we get square roots in our answer. The only thing we have to keep in mind is we're not allowed to have square roots in the denominator of our answer. So if we get an answer with a square root in the denominator, we're going to have to do something about it. All right? So let's tuck that away for a second. We don't need that for the first couple of examples because in the first couple of examples, we're going to be able to get around that. So first example, we have the square root of 6 divided by the square root of 2. I think you could probably guess how we're going to do this problem. Anyone want to guess? If you look at this here, it's the square root of 6 divided by the square root of 2. So D'Artavian's suggesting that we could do 6 divided by 2, which is what? What's 6 divided by 2? It is 3. And he's exactly right. We can do that division. So 6 divided by 2 is 3. But there's something important that we need to do with that 3. Where do you think that 3 should be?
The square root.
Inside the square root. Why?
Why? Because it's been divided by a square root, so it should.
Yeah. To get that 3, we divided a number that's in the square root by a number that's in the square root to get a number that's in the square root. So if you remember when we were multiplying square roots, if we multiply two numbers inside of the square root, two radicands together, we get a radicand. If we multiply two coefficients together, we get a coefficient. All right, so if we're doing a square root divided by a square root, and we divide the radicands, then we get a new radicand. All right, now this is a nice problem because it works out evenly. Can we simplify the square root of 3? No. So we're still going to need to simplify square roots sometimes here. And to do that, we're going to factor it and then pull out pairs. But can I factor the 3? No. So there's no pairs to pull out, so that's just going to be our answer. That's a nice, easy one. Example 2 here is a little more complicated. But I think you could probably figure this one out too. Go ahead and give this one a try on your own. All right, so I was walking around and I saw quite a few people had this written down. What do you guys think about 3 square root of 5 as an answer here? Does that seem pretty good? Okay, I like that answer. That is the correct answer. So let me ask this. Where did that 3 come from? 6 divided by 2, right? So 6 is the coefficient in the numerator, 2 is the coefficient in the denominator. We divide 6 divided by 2 and get 3. And then if we look at the radicands, we have 15 in the numerator and 3 in the denominator. So 15 divided by 3 gives us 5. And since those were radicands, it's going to go on the inside of the square root. Can I simplify this square root? No. Again, the 5 cannot factor, so we're not going to have any pairs, so nothing to pull out. So our answer is 3 square root of 5. Pretty easy, right? So sometimes the problems are going to be really easy, like the first example and the second example, where all we have to do is divide the coefficients or divide the radicands. All right? Sometimes we're not going to be able to do that. So here's example 3. in this example, do you think we can do 6 divided by 2? Yeah. So we cannot do 6 divided by 2 here because 6 is on the outside and 2 is on the inside. And we can't do things with numbers that are on the outside and on the inside. We can't multiply them together. We can't divide them. So we're kind of in trouble here. We can't actually divide this. All right, we have another problem. Our other problem has to do with the very first thing we talked about with dividing, which is what? You're not allowed to have square roots in the denominator. So we cannot simplify this. All right? So this is a little bit tricky, but we cannot simplify this because if we try factoring the 2, we can't do it. So we don't have any pairs. We don't have anything to pull out. The problem is we're not allowed to have square roots in the denominator. All right? So what we're going to do is actually something that we talked about in the opener today, and we're going to multiply by something so that we get rid of the square root here. All right, so let me ask this. What can we multiply the square root of 2 by to get rid of the square root on the 2?
2 squared.
I think you've got the right idea. You just said it wrong. Not 2 squared, but the square root of 2. Okay, so I'm just going to put this here for a second. Let's think about what's going to happen. What is the square root of 2 times the square root of 2? It's 2, right? We talked about that in the opener where any square root times the same square root is going to be the same number, the radicand, but without the square root. So if I do this in the denominator, then I get rid of the square root. The problem is I can't just do something in the denominator without compensating for it somewhere else. So if I multiply by the square root of 2 on the bottom, what do you think I have to do to compensate for that? Do the same thing on top. So I'm going to multiply by the square root of 2 on top also. And the reason I have to do this is because I did it on the bottom. Okay, it's kind of like the golden rule when you're solving equations. Whatever you do on one side, you have to do on the other. Except it's not, because we don't have 2 sides of the equation. When we're dealing with fractions, if we change the numerator or we change the denominator, we have to do the same on the top and the bottom. We did the same thing when we were reducing fractions. We did the same thing when we were getting a common denominator so we could add fractions together. So this is the same thing as what we were doing then, except now we're using it to get rid of a square root. All right, so let's look at what happens here. Once I multiply by the square root of 2 over the square root of 2, then what do we get on top? What's 6 times the square root of 2? Is that 12? Can I multiply the 6 and the 2 together? No, 6 is on the outside and 2 is on the inside, right? So we'll just keep the 6 on the outside. Keep the 6 on the outside and the 2 on the inside. All right, how about on the bottom? What's the square root of 2 times the square root of 2? That's just 2. That fixed our problem, didn't it? So it fixed our problem when we had a square root in the denominator that was not good. We can't do that. But now we don't have a square root in the denominator. All right, we're not quite done though. What else can I do with this? I can do 6 divided by 2, yes. So we have, on the outside, we have a 6 on top and we have a 2 on the bottom, so we can divide those. What is 6 divided by 2?
3.
3. So what we end up with then is a 3 on the outside and 2 on the inside. Let's take a second to write down what we were doing here, because these are the steps that we're going to take most of the time when we're dividing square roots. Usually it's not going to be real easy like the first and the second examples, but usually we're going to have something like this where we have to get rid of a square root in the denominator. All right, so the first thing we're going to do when we're dividing square roots is we're going to simplify the coefficients and we're going to simplify the radicands. So that's the same thing we did in example 2. We divided the numerator divided by the denominator out front for the numbers on the outside, and then we did the same thing with the numbers on the inside. All right, so the first thing we're going to do is we're going to simplify coefficients and we're going to simplify the radicands. Once we have done that, a lot of times we're going to end up with a square root in the bottom. And to get rid of that square root in the bottom, we're going to do the same thing we did in that last example, where we're going to multiply by the square root of whatever that number is in the bottom. All right, so what I'm going to have up here may seem a little complicated, But what this means is the square root of n is the square root that you have in the denominator. So in example 3, that square root of n was the square root of 2. So we multiplied by the square root of 2 over the square root of 2. Just like in example 3, a lot of times after we do this, we're still going to have more stuff we can simplify. So the last thing we're going to do is we're going to simplify again. Alright, so when we're dividing square roots, we start by simplifying, and we end by simplifying. And then this in-between step here, this is really the trick to it. This is what allows us to follow that rule that says we're not allowed to have square roots in the denominator. Alright, so we did example 3. I'm going to go through example 3 one more time, but I'm going to go through just talking about those steps. So first step says simplify coefficients. Can I simplify the coefficients here? No, we really only have a coefficient in the numerator, right? Then it says simplify the radicands. Can we simplify the radicands here? No, because we only have a radicand in the denominator. All right, so once we do that, then we're going to multiply by the square root of n over the square root of n. But in this case, n is going to be what? What do we put in this? Instead of n and n, we're going to put 2's. And the reason we use 2 is because that's the square root that's in the bottom. So we're going to put 2's in here. And so we multiply that out. And on top, one of the biggest mistakes that we see is when people are multiplying this out, they want to multiply the 6 times the 2. Remember, outside numbers stay on the outside, inside numbers stay on the inside. So the 6 is an outside number. The 2 is an inside number. So we get 6 square root of 2. And on the bottom, square root of 2 times square root of 2 is 2. Alright, then the last step, step 3, says simplify. So we look at this again and see if there's anything we can simplify. After this step, we should not have any square roots in the denominator. So we don't have to worry about simplifying radicands because, well, we only have that radicand up top. The only time we might have to do that is if the radicand on top is something we can simplify. But if we did the first step, we won't have to do that. We'll see some examples like that later. So let's simplify the coefficients. 6 divided by 2 is 3. And so we end up with 3 in the coefficient and 2 in the radicand. Okay, same thing we got when we did it earlier. All right, so let's do a new one. So example 4, we have the square root of 3 divided by the square root of 2. So step 1 says simplify coefficients. Do we have any coefficients to simplify here? No. Simplify radicands. We do have radicands, but can the 3 and the 2 simplify with each other? No. Now, if this had been like 3 and 9, then we could have, because we could have reduced the 3 with the 9. But they're not. We can't simplify those. So we skip to step 2. Step 2 says multiply by the square root of n over the square root of n, where n, or the square root of n, is the square root that's in the denominator. So what's the square root in the denominator? 2. So we're going to put 2's in these square roots here. On top, what is the square root of 3 times the square root of 2? Square root of 6, yes. So we don't have any pairs that we're going to be able to pull out, so we'll just multiply those together. Notice that when we're doing division, we're using multiplication also. That's why we had to learn how to multiply first, because we have to know how to multiply 2 square roots together. We get the square root of 6. And then on the bottom, the square root of 2 times the square root of 2 is?
4.
Well, the square root of 4, but the square root of 4 is 2. Remember, any square root times itself is the radicand without the square root. So we just get that 2, but no square root on it. All right. Now, do we have a square root in the denominator anymore? No, so we're okay with that. We just need to check now to see if we can reduce this, simplify it. Can we simplify this? No. Why can the 6 not reduce with the 2? Why can't these reduce with each other? 2 is on the outside, 6 is on the inside. So those will not reduce. That's your final answer right there. All right, example 5. it would be tempting to start this problem off like this, and do not do this. But it would be tempting to say, okay, I see a square root of 10 in the bottom, so I'm going to multiply by the square root of 10 over the square root of 10. Again, do not do this. If you do this, you're going to get the right answer, but you'll have to do a lot of simplifying to get the right answer in the end. All right? So this is the right thing to do if we can't simplify, but we forgot to do step 1. All right? Don't forget about step 1 because it's going to save you a lot of work in the end if you can do it. All right? So look at the coefficients. Can we simplify those coefficients, that 10 with the 6? What goes into 10 that also goes into 6? 2. So even though we can't do 10 divided by 6, 6 doesn't go into 10 evenly, we can still reduce it. All right, and reducing that is going to make things easier on us later. So with the coefficients, we're going to divide the top and the bottom by 2, and we get 5 and 3. All right, looking at the radicands, can we simplify that 6 and the 10 on the inside? Yeah, they're the same numbers, they're just flipped, right? So we can divide both of those by 2. And 6 divided by 2 is 3. 10 divided by 2 is 5. So after we simplify these square roots, what we end up with is 5 square root of 3 on top and 3 square root of 5 on the bottom. All right, now the next step says multiply by the square root of n over the square root of n, where the square root of n is the square root that's in the denominator. What is the square root in the denominator here? 5. So we're going to multiply by the square root of 5 over the square root of 5. On top, this isn't so bad. Actually, the bottom's not so bad either, but it's going to be a little bit trickier. On top, the square root of 5 here, what's that 5 going to multiply with? Is it going to multiply with the 5 in the coefficient or the 3 in the radicand? The 3 in the radicand, right? So the coefficient is still going to be 5. So on the outside we get 5. On the inside we get 15. All right, how about the denominator? This one's a little trickier. Let's do this. Let's start by pretending like this 3 isn't here. So ignore this 3 right here for a second. What's the square root of 5 times the square root of 5? 5. All right, so this part right here is going to be 5. And then what is 3 times 5? 15. So what we end up with in the denominator is 15. We're not quite done. We didn't do step 3 yet. Step 3 says simplify. Is there anything here that can simplify? The 15 here or the 15 here? Or both of those 15s together?
No, 15 and 5.
The 15 with the 5. So this 15 right here cannot simplify if, as long as we reduce this, the 6 with the 10 here, you should not have to reduce this fraction or simplify this fraction. But what we can do here is simplify this 15 here with this 5 here. They're both on the outside, so if they have a common factor, we should reduce by that common factor. So what goes into 5 that also goes into 15? What goes into 5 that also goes into 15?
3.
What goes into 5 that also goes into 15? 5, right? So we're going to divide by 5. What is 5 divided by 5? 1. And what is 15 divided by 5? 3. I think that's what you were thinking when you said 3, right? Okay. So what we get on top then is 1 square root of 15. If we have a 1 in the coefficient, what can we do with it? Or what can we not do with it if we want? We can leave that 1 in the coefficient off, so all we have there is the square root of 15. If you put the 1 there, that's okay. You can do that, but you don't need it. And then in the denominator, you have 3. And that is simplified. Don't try to simplify the square root of 15 with the 3 here, because the 15 is on the inside and the 3 is on the outside. So don't try to simplify insides with outsides. You can only simplify outsides with outsides or insides with insides. So for this problem, once we simplify everything, we get this answer. We get the square root of 15 over 3. Notice that we do not have a square root in the denominator anymore, so this is okay. We have everything simplified as much as we can. We don't have a square root in the denominator, so we're done. All right. One thing that we'll see sometimes, and this would be wrong, is to write something that looks like this. If we have 15 on top and 3 on the bottom, but if you make that square root cover the whole thing, now what does that do to the 3? It puts it on the inside. So if the square root covers the entire fraction, it means something different than if the square root only covers the number in the top. So make sure that your square root covers exactly what it needs to cover and nothing more. If you do this, if you write it like this, then what that means is you have a square root of 3 in the bottom, not just 3 by itself, not 3 on the outside. Does that make sense? So you need to be careful about that. Okay, that'll kind of help us with this one. Some of you have come across problems that look a lot like this on Khan Academy. In fact, some of you have come across problems that look like some of the examples we've been doing already in Khan Academy. The first thing we're going to do with this one is not actually in our notes. We haven't written down a step for this. But what we want to recognize here is that the 1 and the 99 are both where? They're both on the inside. So what we're going to do is we're going to rewrite it, but we're going to rewrite it so they each have their own square root. So we're going to write the square root of 1 on top and the square root of 99 on the bottom. Now, there's 2 things we can do here with this. If we look at the top, what's the square root of 1? 1. That's just 1, right? So we actually don't need that square root on the top because, well, the square root of 1 is 1. All right, let's look at the bottom, the square root of 99. What do you think we might be able to do with that? I think I heard somebody say simplify. Did I hear somebody say simplify? Yeah, we can simplify that. So what we're going to do is we're going to go off to the side. I'm going to write the square root of 99 over here, and we're going to try to simplify that. All right, so how does the square root of 99 simplify? What's the first thing we do? Factor tree. So 99 is 9 times 11, right? 11's prime, but 9 is composite. That keeps going. We get 3 and 3. And so the square root of 99, when we rewrite it, we get the square root of 3 times 3 times 11. And what can we do with that now? Circle pairs. We have a pair of 3's. And so on the outside we get 3. And on the inside we get 11. All right, so all this work that I did down here, this was just to help me figure out what to put on the bottom of this fraction instead of the square root of 99. So the square root of 99 is the same thing as 3 square root of 11. So I'm going to come over here and write that in right here. 3 square root of 11. Now we do still have a problem here. What's the problem that we have? We still have a square root in the denominator. And remember that number 1 rule, we are not allowed to have a square root in the denominator. So we need to get rid of that square root. We did step 1. We simplified the coefficients. We simplified the radicands. This part right here, what we did down here, that was simplifying the radicand. But now we need to get rid of the square root of 11. So we're going to do that next step, which is multiplying by the square root over the square root. What square root are we going to multiply by here? 11. So we multiply by the square root of 11 over the square root of 11. On top, 1 times anything is the same thing, right? So what do we get on top? How about the square root of 11? Right? So 1 times anything is the same thing, so we just get the square root of 11 down there. On the bottom, Again, let's ignore that 3 for a second. What's the square root of 11 times the square root of 11? It's 11. Okay, 11 on the outside. So what's 11 times 3? 33. Can I simplify this? No.
Because if you try just to simplify it, it's going to be.
So since the 11 is inside the square root and the 33 is outside the square root, we cannot reduce those. Okay, if they were both on the outside or if they were both on the inside, then we would be able to, but they're not. So that's it.